Hello students. So in the previous class we were talking about that of the isotopes, and we discussed that what are isotopes and how the different elements or how the element which is having the same atomic number but different mass number. And you see student, there are a lot of elements which is having their isotopes, and we discussed that how isotopes they differ from each other. Okay, so we know that the isotopes they differ from each other by that of the number of neutrons. So only number of neutrons makes them differ from that of each other. It is because of the number of neutrons they are, even though they are having the same atomic number, but they are having the different mass number. So you see student, we discussed a lot of examples. Let me remind you one more time what are the different examples. That is of the hydrogen. So you see hydrogen can exist in three isotopic form, and that is hydrogen 1, hydrogen 2 and hydrogen 3. Okay. Then if we talk about the chlorine students, so chlorine can exist in two isotopic form, that is chlorine 35 and chlorine 37. Both are having the same atomic number, and that is 17. If we talk about that of the oxygen students, so oxygen is having the 8 atomic number and its isotope is 16 and 18. If you talk about that of the carbon, so carbon can exist in a 3 isotopic form. All are having the same atomic number. One is having carbon 12, one is having carbon 13 and one is having carbon 14. Okay, if we talk about the phosphorus students, so phosphorus also exists in 2 isotopic form, and that is phosphorus 31 and phosphorus 32. Okay, and both are having the same atomic number, and that is 15. Likewise students, if you see, there are a lot more examples of the elements which shows their isotopes in the nature, and they only differ just because of their mass number, and actually they differ from each other because of the number of neutrons. So neutrons differ from each other, and therefore there is a difference in the mass number also. Okay. So today we will see, we have understood that what is the isotope, what is their atomic number, what is their mass number, how they differ from each other, even their electronic configuration. So you see here student, there will be no change in the electronic configuration because their atomic number is same. So since their atomic number is same, so we can say that they will not going to differ from each other. Now we will discuss the characteristics of that of the isotope. So, characteristics of isotopes. So, you see here student, what are the different characteristics of the isotopes? So, the first one is the first characteristic. You know that all the isotopes, they are having the same atomic number. So one thing that is common in all the isotopes, that they are having the same atomic number. So we can write it, they are having same atomic number. What does that mean? That if suppose they all are having the same atomic number, it means the number of proton as well as the number of extranuclear electron present in that of the isotopes are same. So we can write it. It means that the number of proton and the number of extra nuclear equal. Okay, so the number of proton in all the isotopes, as well you have seen the electronic configuration. It means the extranuclear electrons are equal. And since you can write it, since number of electrons are equal, thus the electronic configuration is same. So you see here, student, since the extranuclear electrons, since the number of electrons are equal in all the cases, so we can say that if the number of electrons are equal, thus their electronic distribution is also equal, or the electronic configuration is also same. Okay, so they are having the same atomic number. It means the number of proton as well as that of the number of electron is equal. Okay, we will see the second one. So in the second one, students, okay, if they are having the same atomic number, what is the thing which will be common there with them? That is, so if suppose they are having the same atomic number, it means their chemical properties are also same. So we can write it, the chemical properties are same. Okay, so since students, their number of electrons, and you know that only the number of electrons are there which participate in that of a chemical reaction, in the chemical bonding. So we can say that since there is no change in that of the electronic configuration, thus there will be no change in their chemical properties. When they show the chemical reaction, it will not go to affect it. Okay, so since the atomic number is same, so number of electron will be same, and because of that the chemical properties are same. Then the third one, students, the mass number is different. So their mass number is different, student. What does that mean? It means that the number of neutrons which is present, it is different. So we can write it, their mass number is different. It means the number of neutrons are different. Okay, so number of proton and electron is same, but since the mass number is different, so there will be no change in the atomic number. Number of proton will remain the fixed, but when you see the isotopes, you will find that it is because of the number of neutron. It varies, and because of that the mass number is also different. Then the fourth one, student, since the mass number different, since the number of neutron is different, so their physical properties will be different. Okay, so their boiling point, their melting point, their density, it will also vary with each other. So we can say that the physical properties will be different. Okay, so their physical properties will be different, like melting point or boiling point or density, etc. Okay, so since their physical properties is different, it means their melting point, their boiling point, their density also varies, students. Now you see, since there is a change in that of the number of neutrons, So if we are saying that there is a different number of neutrons are present, it means that they are having the different nuclear properties. So we can write it that they all are having they are having different neutrons. Okay, so they are having the different neutrons, or thus having different nuclear property. We can write it different nuclear properties. Okay, so since they are having the different neutron, so they are having the different nuclear properties also, students. So like what, student? The radioisotope. So you have seen that of the carbon 14. So carbon 14 and that of the carbon 12, both are different from each other just because of the number of neutron. So number of neutron in both the cases are different. So we can say that they differ from each other by the number of neutron. It means their nuclear property also varies, and that is why carbon 14 is a radioisotope while this is not. Okay, so carbon 12 is not a radioisotope, but here, just because of the change in the neutron, it starts behaving like that of the radioisotopes. Okay, so most of the elements, most of the isotopes are radioactive, and that is why we use the term for it, and that is radioisotopes. So these are some of the characteristics of the isotope, student. Let me remind you again. So the first characteristic of isotope, that is, they all are having the same atomic number. If all of them are having the same atomic number, it means their chemical properties also remains the same. One more thing, if they are having the same atomic number, it means their number of proton and number of electron is same, and thus they are having the similar electronic configuration. If we talk about the properties, obviously electronic configuration is the same, so we can say that the number of electrons are equal, so electronic distribution is same, and that is why there will be no change in their chemical properties. Then third one is that they differ from each other only through their mass number. Mass number, it means just because of their neutrons. Okay, so protons remain the same, but the neutrons, they vary. Okay, so they differ from each other because of the mass number. Since the number of neutrons vary, so we can say their physical property also differ from each other. Physical property includes the melting point, includes the boiling point, includes its density. All these things are what? These are the physical properties. So they differ from each other by their physical properties. And the last one is, student, since they are having the different neutrons, so their nuclear properties also varies. Okay, it means they are having the different nuclear property. And thus you see some of the elements, they are radioisotope, while the other element they are not. Okay, so these are the characteristics of the isotopes. Now we will discuss about the applications of the isotope. What is the use of this isotope? In the exam, many can be asked the application of the isotopes. So we will discuss the applications. Applications of isotopes. If we talk about the application, students, applications of isotopes. So what is the applications of the isotopes? So you see here, students, isotopes basically. So isotopes, students, many of the isotopes in nature, in most of the elements, if you see their isotopes, They are basically radioactive in nature. Okay, so they are radioactive in nature, and due to that they are radioactive, we use such kind of a isotope. The name of such kind of a isotopes are radioisotopes. Okay, so we use another term for such kind of isotope, and that is radioisotope. Now you see here students, what is a radioisotope? A radioisotopes are basically consisting of extra nuclear and extra neutron. Okay, so since they are having an extra neutron, and due to which they are unstable nucleus. Okay, so these radioisotopes basically students, if you see that these are the consisting of the extra neutron, and since they are having the extra neutron, their nucleus is almost unstable, and due to which student they start emitting the radiation. So they emit radiation, and these radiations are alpha, these are beta, and these are gamma. Alpha, beta and gamma radiation. Okay students, so this radioactive element, they are these isotopes, we use the term for it, and that is radioisotope. And this radioisotope, it is radioisotope because of the extra neutron present in it, as well as if the extra neutron present, so we can say that they are having the unstable nucleus. Okay, so if they are having the unstable nucleus, because of this instability, they used to emit radiation, and these radiation may include the alpha. We use the term for it, that is alpha. Here we call it a beta, and here we use the term for it, that is gamma. Okay, so alpha, beta, gamma radiation is given by that of the radioisotope. Now, these radioisotope students, these are very useful in that of the medical field, in that of the other field of the science. Okay, so we will discuss some of the radioisotope. Okay. So if you see here students, if you talk about the first radioisotope, and that is uranium-235. Uranium-235 is an isotope which is basically used in the nuclear power plant, and there it is used as a nuclear fuel. So we can say that uranium-235 is an isotope of uranium which is used as nuclear fuel in the nuclear power plant. So you see here student, uranium-235, it is an isotope which is basically, there are two isotopes of uranium is there. One is uranium-238 and another is uranium-235. Uranium-235 is basically used as an isotope of uranium, and which we use as a nuclear fuel, and it is used in the nuclear power plant where it will help in releasing an excess amount of energy. Okay, so this isotope is used in the nuclear power plant. There are other isotopes also which we use in that of the medical field, and there it plays a very important role in diagnosis of that of the diseases, as well as it helps in the treatment of the some of the diseases like that of the tumor or that of the cancer. So we will discuss some of the radioisotopes which use or which is helpful in detecting and in treating that of the cancer or the tumor type of dangerous diseases. So you see here students, so the first one is phosphorus 32. So you see here student, phosphorus 32. We discussed that phosphorus is having two different types of isotope. Phosphorus 31 is there and phosphorus 32 is there. So if we talk about the phosphorus 32, so phosphorus 32 isotope is used in the treatment of blood cancer. Treatment of blood cancer. So you see here student, this phosphorus 31 is there, which is not a radioisotope, but phosphorus 32 is a radioisotope, and this radioisotope is used in the treatment of blood cancer, which is also known as leukemia. Okay, so it is helpful in the treatment of that of the leukemia. Then we talk about the cobalt 60. Cobalt 60. Cobalt 60 students. So cobalt 60 is also used in the treatment of cancer. So we can write it cobalt 60 or CO60 is also used in the treatment of cancer. Okay, so cobalt 60 is also a radioisotope which is used in the treatment of that of the cancer, like that of the phosphorus. Phosphorus isotope is used in the treatment of leukemia or that of the blood cancer. Next one is the iodine students. If you see iodine 131. So this iodine 131 is used in diagnosing a disease, and that is the goiter which occurs due to the deficiency of iodine. Iodine 131 is used in diagnosis and treatment of a thyroid disorder. Treatment of a thyroid disorder, that is goiter. Okay, so iodine 131 is used, it is helpful in diagnosis as well as in that of the treatment of a thyroid disorder, which we call as a goiter. If we talk about the next students, so there are some of the radioisotopes which is used to detect the cancerous cell or that of the tumor present in the body. So we can write it. If some of the radioisotopes are used as a tracer to detect the presence of tumor in the body. So you see here student, not only these radioisotopes, there are a lot of radioisotopes there, like that of the sodium 24. So these are some of the radioisotopes which is used to detect the presence of the tumor or that of the cancerous cell. Okay, so these are some of the radioisotopes which is used in that of the medical field. Now, if you see that there are some of the radioisotopes including that of the carbon 14. So carbon 14 is a kind of a radioisotope students which is used in detecting, it is used in carbon dating. Carbon dating is a method by which we can find the age of the fossils. Okay, so not only in that of the medical field, not only in that of the nuclear field, but students, it is also used in finding the age of that of the fossils. So we can write it that carbon 14, that is C14, is used in carbon dating. Okay, so we can write it. It is used in carbon dating. So what is a carbon dating? This is the method by which we can find the age of the fossils. Okay, so we can write it. This method is used to find the age of the fossils. Okay students, so carbon 14, you know that carbon also exists in carbon 12 and carbon 14. So this carbon 14 is used in the carbon dating to find the age of the fossils as well as the age of the old sample of the wood is there. So it will help in finding the age. Okay. Then students, next one is there are a lot of radioisotopes which is also used in detecting the leakage of that of the oil or leakage in that of the gas pipes. Okay, so we can write it. Some of the radioisotope are used to detect the leakage of the underground oil pipes or gas pipe or water pipe. Okay, so these are useful in detecting that is there any leakage in that of the pipe. So leakage of the underground pipes, including gas pipes, water pipes or oil pipes. So you see here students, these are the radioisotopes which is not only used in that of the medical field, but it is also used in detecting the leakage in the oil pipe. So these are some of the applications of the isotopes. Let me remind you again all the isotope students. So the first application is that it is used in the nuclear power plant as a nuclear fuel. So uranium-235, U-235 is used as a nuclear fuel in that of the nuclear power plant. Okay, so it is a radioactive element which is used as a nuclear fuel. Okay, so it helps in releasing a lot of energy, or it helps in that of the nuclear fusion, in carrying the nuclear fission and fusion. Then the second one is that it is this radioisotopes are also used in that of the medical field. So if you see here student, cobalt-60. So cobalt-60 is used in the treatment of the cancer. Not only that of the cobalt-60, but phosphorus-32, P32 is also used in the treatment of that of the leukemia or that of the blood cancer. Iodine-131, it is used in diagnosing and as well as that of the treatment of that of the thyroid disorder, which is also known as goiter. And if you talk about some of the other radioisotopes, so some of the other radioisotopes, they are also used in detecting, they are used in a trace amount in detecting that is there any tumor or a cancerous cells are present in the body or not. Okay, then if we talk about the carbon-14, so this was it is about the radioisotope which is present in that of the which we use in that of the medical field. Now, if we talk about that, they are also used in finding the ages of that of the old sample of the wood or of the fossils. So for that purpose, we use a carbon-14. So carbon-14 is used in the carbon dating. What is carbon dating? It is the method by which we are able to find the fossils, the age of the fossils. Then age of the fossils. Okay. Then these radioisotopes, these are also used in finding the leakage in the underground pipes. That leakage can be a water pipe, that leakage can be a gas pipe, or that leakage can be an oil pipes. So these are some of the examples of that of the radioisotopes. Okay. Now before we go further, student, and understand the concept of that of the isobar, let me tell you a very important concept, and that is to find the average atomic mass. Now you see here, students, these isotopes are there. So a single element can exist in nature in more than one form. Okay, and these elements, they are having the relative atomic masses. Like if suppose we talk about that of the chlorine. So chlorine can exist in nature in chlorine 35 as well as chlorine 37. So you can see here their relative atomic mass is almost similar. And you have seen that most of the elements, they are having the atomic mass in fraction. So why is it so, student? Why the elements are having the atomic mass in fraction? It is because that they are having their isotopes, and these isotopes are present in the nature in a different ratio, but yes, their relative atomic mass is very much similar. Okay, so in that case, student, what we have to find? We have to find the average atomic mass. And the average atomic mass we can calculate with the help of the percentage, the amount of the chlorine 35 or the amount of both of the isotopes present in that nature. Okay, so whenever a question is asked related to that of the average atomic mass, so the percentage of both of the isotopes, the percentage, how much it is present in that of the nature, what is the percentage of existence of these elements in the nature will be given in the question. Let me explain you with the help of an example. If suppose the question is that chlorine 35 exists in a nature, that is the 75%. And that of the chlorine 37 is present in nature, that is 25%. In that case, student, what will be the average atomic mass? So how will you find it? The chlorine 35, the percentage of the chlorine 35 in nature is 75%, and the percentage of chlorine 37 in nature is 25%. So average atomic mass of chlorine will be equal to, students. Now see, what is the atomic mass of this? What is the mass number of the chlorine? That is 35. So 35 into, what is the percentage of the chlorine 35 present in the nature? That is 75. So 35 into 75 plus, what is the mass number of the chlorine which is present in the nature? The second one, and that is 37. And what is the percentage of the chlorine 37 present in the nature? That is 25 upon 100. So you can see here, student, we will see that what is the percentage and what is the mass number of both of the element, and by multiplying and adding both of them, we will get the average atomic mass. So when you will multiply and add it, when you will get the answer you will get is 35.5 U, and that is why in most of the book you will see that chlorine, although we study that chlorine is 35 or chlorine is 37, but here it is always written as a chlorine 35.5. This chlorine 35.5, don't get confused, it is the average atomic mass of that of the chlorine 35 and that of the chlorine 37. 37. So whenever the question is asked related or finding of that of the isotopes, that of the percentage or that of the average atomic mass newtons, so you will apply this formula, percentage into that of the mass number plus the percentage and into the mass number of the second isotope by the help divided by 100. By the help of this, we are able to find the average atomic mass of that particular element. Okay.